Now I want to take a look at solving simultaneous equations using matrices. Now let's take for instance we have two simultaneous equations of 5x plus 2y is equals to 13 and 2x plus y is equals to 7. Now the way to go about this, we can solve this by elimination method or substitution method, whatever method you're familiar with. However, if you want to solve using simultaneous equation, there is a formula to use which is as x is equals to determinant d, y is equals to dy over d, and z is equals to dz over d. Now, with respect to that, what is dx, what is dy, what is dz, and eventually what is d? Now, let's start with d. Now, given 5x minus 2y, 2x plus y equals to 13 equals to 7. Now, d will be the determinant of the coefficients. Okay, that's 5, 2, 2, 1. And that will give us 5 times 1 minus 2 times 2. And that will give us 5 minus 4. Sorry, this is minus 2 here. That's 5 plus 4, and that will give us 9. Okay, so once we will be able to evaluate the determinants, now what about dx? Let's try and rewrite it again. 5x minus 2y is equals to 13. 2x plus y is equals to 7. Now dx is equal, remember we started writing with this, right? And then we have 5, 2, minus 2, 1. Now in the case of dx, we are going to remove the coefficient of x and replace it with this. So that will give us 13, 7. And if you look at dy, let's write dy here. Let's say 5x minus 2y is equals to 13. 2x plus y is equals to 7. In the case of dy, you can remember we started writing it the coefficients individually as 5, 2, minus 2, y. But in the case of dy, we are going to change minus 2, 1, the coefficients of this, and bring this one here. Okay, so the constant is replacing the x coefficient in dx, and the constant is replacing the y coefficient in dy. So when we solve dx, that gives us 13 times 1 minus 7 times minus 2. And that will give us 13 minus minus 14. And that will give us what? 13 plus 14. And that's 27. And in the case of dy, we have 5 times 7 minus 13 times 2. That will give us 35 minus 76. That will give us 9. So we recall that d that we calculated is 9. Dx is 27. Dy is equals to 9. So remember that x is equals to dx divided by x, and y is equals to dy divided by d. And that will give us 27 divided by 9, and y will be equals to 9 divided by 9. So x is equals to 3 and y is equal to 1. So that solves the simultaneous equation. Now what if we have three equations? Take for instance, we have 3x plus 2y minus z is equals to 2, 2x minus y minus 3z is equals to 13, x plus 3y minus 2z is equals to 1. Now in this case, you can simply say that our x is equals to dx over d, our y is equals to dy over d, and obviously our z will be equals to dz over d. Now what is our x? What is our d? Remember, our d will be the determinant of the coefficient of x, y, and z. Okay, so we take the determinant of 3, okay, determinant of this each. That will give us 3, as we have here, 2, and minus 1. 2, minus 1, minus 3. This is 1, this is 3, and this is minus 2. Okay, so in that case, when we solve this, going straight to the answer, we have our d to be 28. Now our dx, in our dx we are changing, let's write it again, 3, 2, 1, 2 minus 1, 3, minus 1, minus 3, minus 2. In our dx we are changing the coefficient term here, okay, we're changing with the x component, okay, so let me label this one blue, and we will change it with what we have here. Okay, that will give us 2, 13, 1. And when we evaluate the determinant here, we will have it to be our dx also to be 28. Now, what happens to dy? In dy, we can also write as we have here, the original 3, 2, 1, 2 minus 1, 3, minus 1, minus 3, minus 2. But in dy, we are going to be changing the y component, okay? We will change it to what we have here, 2, 13, 1, okay? And when we solve the determinant of this, we will have minus 56. And if it goes to dz, we will write what we have here, that we've done in dx and dy, where it's to be 3, 2, 1, 2, minus 1, 3, minus 1, minus 3, minus 2. And for dz, we are now after determinants, the coefficient of z, okay? We're going to change the coefficient of z to the constant term of 2, 13, 1. And after that is done, we can find the determinant and to give us minus 84. Now, having calculated for d, dx, dy, and dz, we can now evaluate for x, which is dx over d, which will give us 28 over 28, that's equals to 1. Our y to be dy over d, which is equals to minus 56 over 28, which is equals to minus 2. And z is equals to dz over d, and that will give us minus 84 divided by 28, and that will give us minus 3. And without wasting much of our time, we want to solve into quotient elimination method. In our next video, we'll be considering on how to solve simultaneous equation using quotient elimination method.